Hello and welcome to all students. In this lecture, we learn about divisibility in Z, and we discuss about the point, new point. Our new today's new point is greatest common divisor. Point number six, greatest common divisor. In short, we call it is GCD. Okay. So first of all, we see some introduction. We know that the meaning of GCD, it means greatest common divisor, and we generally find the greatest common divisor of uh, two or more than two integers. For example, the greatest common divisor of two integers or two numbers 18 and 30 is 6. Second example is the greatest common divisor of two numbers 30 and 45 is 15. And the greatest common divisor of two numbers 90 and 50 is 10. So in this lecture we give a formal definition of greatest common divisor. So first of all we should know how to find a greatest common divisor. Suppose we have two numbers. Consider the case of 18 and 30. Suppose we have these two numbers 18 and 30. To find out its greatest common divisor, we commonly use a procedure like this. First of all, find the all divisors of 18. After that, find all divisors of 30, and among the all divisors of 18 and among the all divisors of 30, we find the common divisors of 18 and 30. Among all these common divisors, we find the maximum of all these common divisors. That maximum number is called as greatest common divisor of 18 and 30. So this is the procedure to find out greatest common divisor of any two numbers. So first of all we define the greatest common divisor GCD in formal language, in formal definition. An integer d is said to be greatest common divisor of two non-zero integers a and b if and only if there are two conditions on d. First condition says that d divides a and d divides b. Second condition is if k divides a and k divides b, then k must divides d. So this is definition of greatest common divisor. An integer d is said to be greatest common divisor of two non-zero integers a and b if and only if first condition says that d is a common divisor of a and b, and second condition says that if there is any other common divisor of a and b, then that common divisor must divides d. Okay. So this is The definition of GCD. A greatest common divisor GCD of two integers a and b is denoted by notation into bracket a comma b. If d is the GCD of a and b, then d is equal to into bracket a comma b. So remember the notation for GCD of a and b. We write some remarks about the GCD. The positive GCD of any two integers whenever exists is unique. The positive GCD of any two integers whenever exists is unique. जर दोन इंटिजरचा GCD एक्झिस्ट होत असेल तर तो GCD एकच असतो. Greatest common divisor of any two integers is only one. It is unique. The GCD of 0 with 0 is not defined because in definition of GCD says that the GCD of two non-zero integers exist. Here both are 0. Therefore, the GCD of 0 with 0 does not exist or is not defined. The GCD of integer a with 0 is a for all a not equal to 0 in Z. This property says that GCD of any integer a with 0 is always equal to a, and it is true for all non-zero a in Z. The GCD of AB is same as GCD of BA. This says that the GCD of AB is same as GCD of BA, and it is true for all AB belongs to Z. The GCD of A comma 1 is always equal to 1 for all A belongs to Z. For example, GCD of 8 with 1 is 1. GCD of 100 with 1 is 1. So for any integer a, GCD of a with 1 is 1 for all a belongs to Z. Next, we define what is meant by relatively prime integers. Definition is two integers a and b are said to be relatively prime or co-prime if and only if GCD of a and b is equal to 1. Once again, the two integers a and b are said to be relatively prime or co-prime if and only if GCD of AB is equal to 1. For example, the numbers 3 and 5 are co-primes, or we can say 3 and 5 are relatively primes because GCD of 3 and 5 is equal to 1. The number 12 and 49 are co-primes. The number 12 and 49 are co-primes because GCD of 12 and 49 is 1. Example third, the numbers 21 and 16 are also co-prime because the GCD of 16 and 21 is 1. One more remark I want to mention here. The GCD of prime number with any other number is always equal to 1. See here once again, the GCD of prime number with any other number is always equal to 1. Therefore, any number with a prime number or any number and a prime number are always co-primes. For example, 10 is any integer and let us take a prime number 7. 10 and 7 they are co-prime. Then 11 and 7 they are co-prime. 12 and 7 they are co-prime. 13 and 7 co-prime. So any other number with the prime number is always a co-prime. Let us consider the next definition of Euler's phi function. Definition: the Euler's phi function of a prime the Euler's phi function of a positive integer n is denoted by the notation phi of n, and it is defined as the number of positive integers less than n and relatively prime to n. The Euler's phi function of a positive integer n is denoted by notation phi of n, and it is defined as the number of positive integers less than n and relatively prime to n. Okay, so phi of n function is called as Euler phi function, and phi of n is nothing but a number of all those positive integers which are strictly less than n and which are relatively prime to n. Okay, for example, consider phi of 1. Phi of 1 is 0 because there is no integer less than 1 and relatively prime to 1. Consider second example, phi of 8. Euler phi function of 8 is equal to 4 because 1, 3, 5, 7 are the positive integers which are less than 8 and relatively prime to 8. Okay. Now consider the next example, phi of 10 is equal to 4 because 1, 3, 7, 9 are the 4 positive integers which are less than 10 and relatively prime to 10. Therefore, phi of 10 is equal to 4. So similarly, we can find all the values of Euler phi function of positive integers from 1 to 1, 2, 3 dot dot dot. Let us take one homework for you. Find the value of Euler phi function phi of 1, phi of 2, phi of 3, phi of 4, phi of 5, phi 6, phi 7, phi 8, phi 9, phi 10, phi 11, phi 12. So in your notebook, try to find out all these values. Okay, and while finding values, if you have any problem, you can discuss me on a WhatsApp number, or you can call me, or you can email me. And to see more videos, you can uh, go to my channel, YouTube channel. Okay, so please, if you have any problem, you can ask and feel free to contact to me. So we stop here. Our lecture is over. We stop here. Thank you. Thank you very much.